Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me RouterBob. Today we're going to make LED signs out of cast acrylic, and I think you're going to find this very interesting.
Hey, RouterBob.
Shawn, a couple years ago, we made an LED sign, and it came out really nice, but the base was real complicated, and the base was used to illuminate it. I found these. What do you think?
I like it. So you just route a hole in it, and it's going to light up the whole sign.
Yeah.
Use this to put on a wall?
Yep. Yeah, have we got some material we can make a sign out of?
We do. I've got extruded acrylic and cast acrylic.
Okay. I think the cast will be better for the engraving function, so why don't we use that?
We can do that. You got a file for me?
I'll go make you one.
All right.
Right. This is really how you start. So you start with the drawing. To give you an idea, the sign is going to be 28 inches long, and then it's proportional to the ShopSabre logo. Now, what we're doing is we're actually going to take a V-bit, and we're going to cut this as a pocket behind with about 25 thousandths deep. So it's not a huge cut at all. We want the back to be very consistent because when the light hits it, you can tell if it's not. So that's the first thing is we locate that. And then this is the outside. And then these are where the 4 holes go. Those standoffs actually fit through that hole, and then it screws together in holes. And then those go up against the wall. Now, in an ideal setup, the wires go in behind the wall, and so that you can't see them. Now, you could also have the wires coming out visibly, but I didn't want to do that. In our case, since we can't really cut a hole in the wall, I went ahead and decided to make a board behind it so that we could conceal the wire so you could see the real effect. So the first thing we're going to do is actually create the tool pass for this. Now, the material is 1/4 inch cast acrylic. Be sure you use cast. The extruded doesn't cut as well. And this is a really critical operation because you can see the edges. So you want to do the best you can on creating a great edge finish. And to tell you the truth, what I usually do is I call over at Vortex and I say, hey, what's the best tool to do this? And I ask 2 things. What's the spindle RPM and what's the chip load? So that's how we do that to start with. Now, let's just take a look at the tool pass. Okay, so the first thing is I created just a V-carve pocket, and I'll show you what it looks like. That's where the tool paths are. All right, and then I machined the holes out, and when I machined the holes, I really just made a spiral cut, and then I did it. The outside's really critical. We did this a couple ways. One, we started out with a rough cut, and I did it in 2 passes. I left 15 thousandths. I did a climb cut because I typically get better edges on that. And then here's the other thing I want you to notice is how I did the lead in, lead out. Now, this is a radius lead in, lead out. It's a fairly large radius, and it comes in on a tangency point. What I wanted to do is I wanted to start, make the cut, come back around and leave, and not hesitate so you can't see any change. And that's a way you do that. Find a tangency point and radius in with a fairly large radius. Okay, we left 15 thousandths. In fact, if I show this, you'll see that. You can see the 15 thousandths. And then we came back and did a finish pass, so it's a single pass. Once again, it's the same tool path, a single pass. This time we took out the allowance, and that's how you get that beautiful finish that we produced. Before we look at the simulation, let's stop and talk about one of these tool paths. Let's look at the finish one because this is what produces what you see. First off, it's a Vortex 3H tool. It's a single flute, and it's an O Flute tool. All right, now let's look at how that's set up. First off, it's a single flute, and that lets us run much higher RPMs and maintain the same chip load. So we're running 24,000 RPMs at 190 inches a minute. It gives us a chip load of just under 8 thousandths. That's the magic. The higher RPMs, I think, help you get better edges in acrylics. So that's how that was done. Now let's go look at simulation. So we'll go to simulation. We'll go to 3D. All right. The first thing that happens is the 90-degree V-bit. It's just used as a pocket tool. So we pocket that out. That gives us a consistent background. Okay. Then we cut the holes with the single flute tool. and then we do a rough pass, and then we do the final finish pass. And that's really all it takes to produce that. One of the things I really like about V-Carve now is the ability to have more than one sheet, and that's what this is. And so I can turn that on. There's a melamine and another sheet. The beauty of that is that I can do multiple setups for the same project in the same program. Now, let's think about what happens on a LED light like this with those standoffs. That would really be off of a wall. But we don't have the luxury of cutting through the sheetrock, so I thought, well, we'll just make something out of white melamine, and we'll cut some recesses in the back, and then we'll use that to display it. So here's basically what I did. I needed holes for the wires to pass through. That's what these are. I needed an area to handle the wires, all right? I needed an area to handle the little junction box that the wires plug into, and I needed something for the wire to route. So let's do this. So here's the pocket, all right? And then these are the holes, and they're machined. They go all the way through. And then there's this deeper pocket because that junction box is a little deeper. And then here's the groove so that the wire exits that goes down to the power supply. And then here's the outside. So if we simulate this, here's what happens. Our pockets get cut. There's the first one. Okay, then the holes. Okay, then the deep pocket. Then the groove. And finally, we cut the outside. And so that produces the board. Now, it's showing wood grain here in practice. It's actually white melamine, and then when we're finished, we'll edge band it. But when you look at the other side, all you have are 4 holes that come through for the wires to pass through. And so that gives us a way to display this sign really nicely. We've got our tool pathing complete. Let's send the files down to CNC Shawn, and let's see how this LED sign comes out.
All right, I got the files from RouterBob. We're going to start out cutting our acrylic. And for our first tool, we're going to use a 1/2" 90-degree V-bit. It'll give us a nice consistent etching in the back and the logo. For our second tool, we'll use a 3/8 O Flute. It's a single flute tool. That'll give us a really clean cutout when we cut the sign out. And then we're going to switch over to cutting our melamine. The first tool we're going to use for that is a 2-flute 1/2" down cut. We're going to use that to cut out a bunch of the material in the back to allow wires to go through. The second tool we use is a 1/4" 2-flute. That's just going to clean it up a little more. And finally, our third tool, we're going to use a 3/8 mortise compression bit to clean everything up, cut it out, and we'll be good to go. Now that we've got all of our bits covered, let's load up our first sheet of acrylic and get started.
Shawn, that sign really came out great. That LED really makes it pop, and those mounts work great.
Yeah, I like your find on that. I mean, you could use these in a lot of ways. The way they would mount to a wall, you could stand it right off there. It turned out great. But you know what really shines is the ball screw technology of this machine. These edges are really clean. The etching, the way that LED, and it just grabs it, really looks nice.
It's a beautiful job. Well, I hope you enjoyed the video. If you'd like to see more videos like this, be sure and subscribe to our YouTube channel. If you have any questions, you can contact us at ShopSabre.com.
And be sure to check us out on Facebook and Instagram.
Thank you for watching.